Good afternoon, students. Welcome back. Welcome to Mr. Chen's master class for pre-calculus. So this one, section 5.3, solving trigonometric equation. So which is the same as section 7.5 for this unit. Okay, so we'll take a look at some of the problem, especially the one that it's considered kind of difficult, rigorous. Okay, so find all solution of the given equation. Okay, so started with that 1a. Okay, so you know what? I'll just snip this whole thing. Okay, we'll do some of those there. So find all solution, that means we can go around the unit circle as many times as we want. So either we can go by clockwise or counterclockwise. Okay, so the first one, so cosine of x minus 1 equals 0. So the way to solve for the first one, so basically we just want to isolate the constant. And then we do know that the unit circle, if we go around the unit circle, finding that the position f1, so we got 1 comma 0, so that means either f1 radian or 2 pi. If we keep going, then that would be considered what? 4 pi. So the way to state that all the solution here, it could be considered x equals 0 plus minus 2 pi k. So word k, it's the numbers such as what? 0, 1, 2, 3, 4, so on and so forth. Okay, so this one including the 0, so we can say that it's what? It's a whole number. So word k, it's a whole number. Okay, so word k, it's a whole number. The reason why it's minus, because that we can go around either by clockwise or counterclockwise. Okay? And now what about for b? So 2 cosecant square of 2x minus 2 equals 0. So isolate the constants, so we do have cosecant square of 2x, or 2 times cosecant square of 2x equals 2. Divided by 2 both sides, so we do have cosecant square of 2x equals 1. Square root both sides, so we do have cosecant of 2x equals plus minus 1. Now instead of using 2x, so let theta equals 2x. So let's solve for theta first. So keep that in mind, theta. So that's just the replacement for 2x. So the 2, what does that mean? So that means we need to find out the solution with 2 repetition. Okay, with 2 repetition. But this time you want to find out all the solutions. So let's find out the 1 in that theta first. So for the first pair of solutions, so we do have up here cosecant of theta equals 1. So that means sine of theta equals 1 or negative 1. So it's either pi over 2, 3 pi over 2. Okay, so pi over 2, 3 pi over 2. And what else could that be? Could be what? Plus minus, right? Because could be going either by clockwise or counterclockwise. Plus minus. So that's considered one cycle. If we go to the second cycle, then that would be plus minus. You just keep adding it. 5 pi over 2. 7 pi over 2. Like that. Okay? For the other cycle. And now you want to solve for x. So once you solve for x, and then you just want to unsubstitute. So basically divided by 2. So divided by 2 for all the solution here. So what we found here is plus minus pi over 4. Plus minus 3 pi over 4. Plus minus 5 pi over 4. Plus minus 7 pi over 4. So the way to come up with the solution here, so it's like every 90 degree. Okay, so every 90 degree we'll come up with the solution. So started with pi over 4, 3 pi over 4, 5 pi over 4 by 90 degree. So plus minus, so theta equals plus minus pi over 4. Also plus minus can just say that positive pi over 4 plus minus pi over 2k. So where k is any natural number. Okay. And now what about for c? Okay, so let me just clear all the annotation. Okay, so for c, so we do have secant square of x. Okay. Well, to rewrite it as 1 over cosine square of x minus 16 over cosine of x. So equals cosine square of x minus 16 cosine of x. So multiply by the LCD. So multiply by the LCD here, would you have, I'll just multiply everything by cosine square of x. So we got 1 minus 16 cosine of x. So that equals cosine to the power of 4 x minus 16 cosines to the power of 3 x. And it looks like this one we can factor by grouping, but before we factor by grouping, let's bring everything all together to one side. So we do have cosine to the 4th power of x minus 16 cosine cube of x, and then plus 16 cosine of x minus 1. And then factor by grouping. So we try to factor by grouping here. So what we can do, we can take out that. Well, let's just regroup them first. I mean, you can just put it this way as, you know, the group here. So take out the greatest common factor, cosine cube of x. So we do have cosine of x minus 16. And this one here, we do have okay, if you try to do it this way, then that'd be kind of weird. Okay, so let's just regroup them. Okay, so let's regroup them. So like cosine of x to the power of 4. Okay. Minus 1. And then this one here, take out the negative. So 16 cosine cube of x minus 16 cosine of x equals 0. And then what we can do, we can factor out. So this one is the difference of 2 squares. So cosine square of x minus 1. Cosine square of x plus 1. And then the other group here, take out the greatest common factor. So we do have 16 cosine square of x minus 1. So the common binomial, so take out the common binomial, so we do have cosine square of x minus 1 times the quantity, cosine square of x plus 1, and then minus 16. So this one factors, so we do have cosine square of x minus 1 equals, well, times cosine square of x minus 15. And now we just want to separate them out. So cosine square of x minus 1 equals 0. And what else? Cosine square of x minus 15 equals 0. So cosine of square of x equals 1, square root, plus minus 1. So again, this one is quite similar to what we did for the first one, but it's plus minus 1. So that means could be 0, could be pi. Again, plus minus pi, plus minus 2 pi, so on and so forth. The way to rewrite it, so 0 plus minus pi k, and where k is any whole number. Okay, so what about for this one? So cosine square of x, so that equals 15 square root. So that means cosine of x equals plus minus root 15. Well, this one, that doesn't make sense because that the range of cosine of x is bounded from 1 and negative 1. So anything that's greater than 1 or anything that's less than negative 1, we talked about that for the previous video. So x has no solution. So this one, there's no solution. Okay? So now, what about for D and E? Okay, so check it out for D and E. So for D, so this one, well, it looks like we need to bring everything together to one side because everything is written in terms of, well, right now it's written in terms of cosine and sine, but we want to rewrite it as sine. So bring that to the left-hand side. So we do have 2 cosine square of x minus 5 sine of x. And then plus 1, so that equals 0. Rewrite it, so we do have 2 times 1 minus sine square of x minus 5 sine of x. Plus 1. And now you want to distribute, so it's 2 minus 2 sine square of x minus 5 sine of x plus 1. And then rewrite it from the greatest power to the least. So 2 plus 1, 3. And you might be wondering, is this factorable? Well, before you factor it, so probably you want to divide everything by -1. So we got 2 sine square of x, multiply everything by -1, or divide everything by -1. So 2 sine square of x plus 5 sine of x, and then minus 3. So we got 2 sine x, sine x. So in order to get 5, so let's say we have 3 here, and then -1 right here. Again, set equal to 0. So we got 2 sine x minus 1 equals 0. So that means sine of x equals 1/2. So in order to have 1/2 positive, so it's quadrant 1, quadrant 2, reference angle, or the first solution, which is what, pi over 6, excuse me, 30 degree, and also 5 pi over 6, again, plus minus. So the way to come up with the solution here, so is what, plus minus pi over 6, plus minus 2 pi k. And then in order to have another solution here, so then that'll be, well, simply just subtract from pi over 6, or 5 pi over 6 plus minus 2 pi k. Again, where k is any integer. Okay, like that. And now, what about for E? Okay, so it looks like that one involved with the double angle. Again, it's just like going around the unit circle twice, double, 3 times. So this one you can just set that sine of 2t equals 0, cosine of 3t equals 0. So again, let theta equals 2t. So sine of theta equals 0. So that means theta equals 0 pi. But once you divide it by 2 and substitute, then you have 0 pi over 2. And then the rest of that is just a repetition. So this one could be 0. What else? Could be pi over 2 plus minus well, that's just one cycle. Okay, if you just go to the second cycle, then that'll be considered 3 pi over 2. Okay, and also pi. Okay, so pi over 2, 3 pi over 2, and also 4 pi over 2. Okay, so on and so forth. So that means we got 0 pi over 2, 3 pi over 2, and then 2 pi. Okay, so all that. So this one is just for the first cycle. This one is for the second cycle. So the way to put it in, it's what? Pi over 2 plus minus. Plus minus pi over 2k. Okay, so where k is any integer. Well, this one pi over 2 to 3 pi over 2, so it's actually plus pi k. Okay, plus minus pi k. And then 0, 2 pi. So we can say that 0 plus 2 pi k plus minus. So gotta be careful. This one k, it's any integer. But k here, it's any whole number. Okay. And then what about for cosine of 3t equals 0? Excuse me. So that means for the first cycle, so that would be considered pi over 2. Okay, so for 3t, so t would be pi over 2. Again, let 3t equals alpha. So alpha equals pi over 2, 3 pi over 2. The second cycle, then that would be considered 5 pi over 2, 7 pi over 2. Keep going. And then 9 pi over 2, 11 pi over 2. Again, it's all plus minus, plus minus, plus minus. So again, this one is just the repetitions by adding 180 plus minus pi k, like that. So, oh, you know what? Divided by 3. Because 3t equals alpha. So t divided by 3. So this one, oh, you'll find out a lot of solution here. So pi plus minus pi over 6 plus minus divided by 3. So 3 pi over 6, so pi plus minus pi over 2 plus minus 5 pi over 6 plus minus 7 pi over 6 plus minus 9 pi over 6 and then plus minus 11 pi over 6. Okay, so let's see that the solution here. So pi over 6, 2 pi over 2. By adding 2 pi over 6. So this one is simply by adding plus minus. So you want to put in like a general solution for all this. So pi over 6 plus minus 2 pi over 6 plus minus pi over 3k. So where k is any integer. Okay. So once you get to the high, the high rigorous one, so you got to be careful with the number of cycles that you have to go around. So if that's 3t, that means you have to go around the unit circle 3 consecutive times. 2t, that means you have to go around the unit circle twice. Okay. So now let's see what else that we have for this lecture, for this part of the lesson here. And 5.3, again, it's the same as section 7.5. Okay, so solve each equation in the interval from 0 to 2 pi. Check for the extraneous solution. So the one that I mentioned about, so sine of 3x, cosine of 3x. So you want to put it in terms of one of the trig functions. So for 2a, so you probably want to bring everything together and then try to square both sides to make the factor. Okay, so to simplify it. So this one is something we talked about before. Okay, so again, just want to give you the hint. Okay, so again, just put it out. So 2a So there's another part of the lecture regarding solving trigonometric equation, and that's the one I'm going to put it along with the similar lessons. So you probably want to watch that one as well. Okay, if you have hard time to follow through this one, because some of the problem here is a lot more rigorous compared to what I have done previously. Okay, so if we just bring everything together to one side, so we do have sine of 3x minus cosine of 3x. So that equals 1. Okay. And then you might be wondering, in order to get the ratio to 1, so what can we do right here? Now, if you try to square both sides, so once you square both sides here, so we do have sine square of 3x minus 2 sine of 3x cosine square of 3x plus cosine square of 3x. So that equals 1. And then sine squared plus cosine squared, it's always considered 1, the Pythagorean identity. So 1, 1, 1, it's all cancel. So 1, 1, both sides got canceled. So what's left here is just negative 2 sine 3x. We don't need that square because that's a binomial expansion. Times cosine of 3x equals 0. So that means sine of 3x equals 0. Cosine of 3x equals 0. So what are those solutions right here? If that's the case, again, this one going around the unit circle 3 consecutive times. So let theta equals 3x. Okay, so for the first cycle, so that means theta equals 0 or pi. And then this one here, again, let theta equals 3x. So for the first cycle, so that would be considered pi over 2, 3 pi over 2. And then the second cycle, then that would be considered 2 pi, 3 pi, and then over here, then that would be considered 5 pi over 2, 7 pi over 2. And then for the third cycle, then this one would be considered 4 pi, 5 pi. And then this one here, then that would be considered 9 pi over 2, 11 pi over 2. And don't forget, divided by 3 eventually. Divided by 3. And other thing that I just want to check, the restriction. So it looks like there's a restriction for this type of problem. From 0 to 2 pi. Okay, if you find out anything that's outside, the range, so that won't make sense. So this one just from 0 to 2 pi. Okay, let's see right here. So it could be 0. Okay, let's just rewrite it. So theta could be 0, pi over 3. What else could that be? And then 2 pi over 3. Pi. 4 pi over 3. 5 pi over 3. And then what about this one right here? Pi over 2, 3 pi over 2, 5 pi over 2. Could be pi over 2, 3 pi over 2. But it cannot be 5 pi over 2 because that's more than 360. More than 2 pi. So pi over 2. Oh, pi over 6. Once you divide it, because you divide it by 3. Okay, so it could be pi over 6 right here. 3 pi over 6, which is pi over 2. 5 pi over 6, that worked. 7 pi over 6, okay? And then 9 pi over 6, reduce it, which is 3 pi over 2. And then the last one, 11 pi over 6. So they all work. Again, this one is being bounded from 0 to 2 pi, and 2 pi is not included. Okay? So for B, C, and D, so B, you probably want to cross multiply and then rewrite it in terms of sine and cosine. And then C, you want to factor it. Okay? But D, that one looks a little bit tricky. Okay, let's do D. Okay, so for D, let's see what we got here. Okay, so secant square of x plus tangent square of x, so that equals cosine square of x. Okay, so let's just rewrite that tangent square of x in terms of secant square. So we do know that secant square of x minus 1 by using the Pythagorean identity. So combine the like terms. So we do have 2 secant square of x minus 1 equals cosine square of x. Again, rewrite it. So it's 2 over cosine square of x minus 1. So that equals cosine square of x. Multiply by cosine square of x. So we do have 2 cosine square, cosine 2 minus cosine square of x. Again, multiply the least common denominator. So we do multiply by cosine square of x. Okay, so this one is just 2. And then this one here distributes. So it's cosine square of x. Then equals cosine to the 4th power of x. Again, bring everything together. So cosine to the 4th power of x plus cosine square of x minus 2. So that equals 0. And then try to factor it. Smiley face. Cosine square of x. Cosine square of x. Negative 2. So let's make it 2 and negative 1. So cosine square of x plus 2. Cosine square of x minus 1. And then set equal to 0 separately. So set that equal to 0 separately right here. So we got cosine square of x equals negative 2. Cosine square of x equals 1. So square root both sides. Well, this one cannot be imaginary solution, so that means no solution for the first factor. Second solutions, well, the second factor. Square root both sides. So cosine of x equals plus minus 1. So if that's plus minus 1, so that means could be what? 0, pi. Again, 2 pi is not included, so it's just 0 and pi for that. Okay, so now let's see what else that we have for the rest of this. Okay, it's a lot of practice problem here. So again, the one that I leave that in blank, so those are the one I do expect you to finish. Okay, so it's quite similar to the one that we've been doing. And let's do the one that it goes from negative 2 pi to 2 pi. Okay, so solve the equations on this specific interval. Okay, so for number 4, A and B. Okay, number 3, I'll go back to it, but let's do number 4 first. Okay, so it looks like this one, it's a non-special ratio, so we have to use a calculator for this. Okay, so sine of x equals 3/5. So this one, it goes all the way from negative 2 pi to 2 pi. Okay, so that's negative 2 pi to 2 pi, so that means it's from here all the way back to 2 pi. Okay, so go around the unit circle twice. like that. Okay, so sine of x 3/5. So that means x equals inverse of sine of 3/5. Okay, so whatever the ratio that you find out for this one, so that means it's going to be one of the angle in the first quadrant, and also it could be the angle in the second quadrant. Okay, because sine, the ratio is positive, it's either in the first quadrant, in the second quadrant. So whatever that you find out for the first quadrant, second quadrant, and don't forget to add that 2 pi k. So k would be what? 1 and 2, because you have to go around a unit circle. So once and then twice. So with two different directions, positive and negative. Okay, so whatever that you find out for x, so that would be the first solution. Okay, in order to get the second solution, so you want to subtract this angle from pi. Okay, because that it's a reference angle here in quadrant 2. So for the second solution, so it's pi minus x. But this one, that just take care of the positive. What about for the negative? So for the negative, so that means it's going backward, going this way. Okay, so if that's consider positive ratios, so in order to get the negative, so then that means it's going to be, well, this one is 0, negative pi over 2, negative pi, negative 3 pi over 2. So whatever that is, the third solution, and then this one will be considered negative pi minus x, because that's going backward. And then for the fourth solution, we're going by clockwise, and then that would be considered negative 2 pi plus x. Okay, so first solution, just do it on the calculator, and then second solution is pi minus x. Okay, right here, going by counterclockwise, and then going by clockwise. So negative pi minus x, negative 2 pi plus x. Okay. This one would be counterclockwise. And this one is quite similar. So this one, it shows that the restriction from 0 to pi. So before you do that, okay, so negative 1/10, so let 2x equals theta. So solve for the inverse of cosine of negative 1/10. So that equals theta. So this one will give you the obtuse angle. So whatever the obtuse angle, you'll find out the first solution, because that is a negative ratio. So it should be showing that it's an obtuse angle. So theta is obtuse. So once you put in this one on the calculator, first solution. And what about this one? It goes, okay, from 0 to pi. Okay, but the thing is that's 2x. Okay, so the one that we found, so theta, is just 2x. So once you divide it by 2, so we have to go around that one more time. So go around that one more time, so you get another angle. Another angle would be considered theta plus 2 pi. And then whatever the answer that you have for theta, and guess what you have to do for x? Divided by 2. Okay? And then the other solution also, divided by 2. Okay? Like that. Again, so the one that we found, once we take the inverse, that just gives you the answer for the angles of 2x. Okay? So once you divide it by 2, and then you get a measure of x. Okay? So for the other solution as well, the second solution, so once you add 2 pi, and then the sum divided by 2. Alright, so it's kind of tricky for this type of problem, because once it's either by going to a different direction, the other one is like 2 cycle. Okay, first cycle, second cycle. Okay, so now let's see what else that we have for the rest of this. Okay, so as what I promised, number 3. So solve the equations 1 plus 1 over tangent square of x times 1 minus 1 over cotangent square of x equals 0. Okay. And then the intervals from negative pi to pi. So now this one is already a factor. So this one is already a factor. So what we can do, we can just simply set each one of the factors equals 0. And then from here, we just want to simplify it a little bit more. So that means 1 over tangent square of x equals negative 1. And what this one is showing here, it's 1 equals 1 plus 1 over cotangent square of x. Okay, so cross multiply. So what we found here, it's negative tangent square of x equals 1. In other words, tangent square of x equals negative 1. Okay, does that make sense? Square root both sides, it's going to be imaginary number. It's impossible. Okay, but what about this? Would that be possible? Cotangent square of x equals 1. Square root both sides. So that means cotangent of x equals plus minus 1. So when does that happen? Cotangent of x equals plus minus 1. So that means x could be what? Pi over 4. Okay. All 4 quadrant. Okay. Okay, so pi over 4, 3 pi over 4, 5 pi over 4, and then 7 pi over 4. And also it could be negative going this way. So this one's going by counterclockwise, but going by clockwise. So it could be minus pi over 4, negative 3 pi over 4, negative 5 pi over 4, and then negative 7 pi over 4. Okay, a solutions. Again, this one, if it fits with the domain. Let's see, that pi over 4, it does. 3 pi over 4, it does. But what about 5 pi over 4? No, it's out of the range. 7 pi over 4 is out of the range. Negative 5 pi over 4, it's out of the domain. So it's only pi over 4, negative pi over 4, 3 pi over 4, negative 3 pi over 4. So it's only 4 solution. So whatever the solution that you find out, make sure that you need to check with the restriction, the given domain. Okay? And now let's see, let's do one more. Again, the one that I just leave that for you, so that means that's something you want to solve by yourself. And number 5, cotangent of t over 2 minus root 3 equals 0. So this one is just solving for cotangent. Again, t over 2, kind of like a half angle, but you can always pretend that angle is theta. And then theta, you only want to take half of a cycle, okay, for that angle. So find out the first solution, and then, well, but the thing is that half, so you have to go around. This one's from 0 to 8 pi. So you have to go around that, the unit circle, 8 consecutive time. No, not 8 consecutive time, 4 consecutive time. Because every 2 pi is considered one cycle. So 4 pi, another cycle, 6 pi, another cycle, 8 pi, so 4 times. So find out, the solution in each dose quadrant. Okay, so it looks like we do have 2 solutions from each cycle. And then multiply by 2. But for number 6, that's the last one I would like to talk about here. Okay, so solve the equation. And looks like this one is non-factorable. So what happens if that's non-factorable? So going back to what we did in chapter 3, polynomial. Again, this one can be always written as y to the power of 3. So you can say that y equals cosine of x. Okay, let y equals cosine of x. So it's y cubed minus 3y squared plus 4. And then the way to find the zeros, again, if that's non-factorable, we need to apply the rational zero theorem. So p over q. So 4 over 1, so plus minus 1 plus minus 2 plus minus 4 and then denominator plus minus 1. And then synthetic division. So we got 1, negative 3, y to the first power is missing, so that's 0, 4. And then started off with, well, this one here, the most dominant, well, which one has more, the even number. So let's start it off with negative 2. So bring down the first number. So we got 1 times negative 2, negative 2. Combine them, negative 5. This one would be 10, but that would be too big. Okay, it won't work. But let's try positive 2 and see what happened. So first number, bring it down. So 1 times 2. Okay, then that'd be 2. And then combine them. So then that'd be negative 1. Negative 1 times 2. Negative 2. Combine them. Negative 2. Negative 2 times 2. Negative 4. Bingo. So what we found here is y squared minus y minus 2. And then times y minus 2. Okay, so it's always the conjugate. And then factor it, so we do have y minus 2. So this one would be y plus 1. And then y minus 2. Okay, so y minus 2, that appears twice. So that means this one is showing, well, y, what is that? Cosine of x. So cosine of x minus 2, quantity square. And then rewrite it and substitute or unplug. Cosine of x plus 1 equals 0. See that? It looks like non-factorable, but try to replace that with a new variable using that rational zero theorem, synthetic division, and you'll find out that it's all factorable. Again, once you combine this together, so it's y minus 2 quantity square. And then y plus 1. Rewrite it in terms of cosine of x for y, so cosine of x minus 2 quantity square, cosine of x plus 1, set equal to 0. So what this one is showing here is cosines of x minus 2 square equals 0. Multiplicity is 2, we do know that. So cosine of x equals 2. Well, is that possible to have cosine of x equals 2? It's impossible. Because cosine curve, the range, it's always bounded from negative 1 to 1. It's a bell curve. So anything that's greater than 1, it's impossible. So there's no solution for this. The only solution is that cosine of x equals negative 1. So when does that happen? So find equation. And this one, it doesn't tell you the restriction. So how do you find out, well, what is the restriction? The restricted range. It's always from 0 to pi, according to the inverse trig function. Again, if that is not seeing any kind of all solution or any kind of specific interval, then we have to use that the given restricted range. The mandated restricted range. So inverse cosine of x, the restricted range. So what is it? It's always from 0 to pi. So negative 1, which is over here. So the answer is what? Pi. Just like that. Again, why do we have the mandated restricted range? Because we need to satisfy the functions. You know, the inverse, it's also considered a function. Okay? So make sure that you guys spend more time to rewatch this lesson, you know, especially the part of the content you do have difficult time to deal with, especially the one that we talked about previously, the one with the given restricted range, and the one without the given restricted range, and finding all solution. And then the last one we did, okay, the one without the restricted range, but you have to find a solution with the mandated restricted range. Okay? So thank you for watching the video today. So I'll see you guys next time. And don't forget to click the like button or subscribe to the channel. Alright, you guys have a great one.